You know d by dx of x raised to n is n x to the power of n minus 1. Here n is equal to 4. X to the power of 4 minus 1 is 4x cube. A sin x minus into minus plus b cos x minus a sin x plus b cos x from equation number 1 is y. It is given. Differentiating with respect to x. dy by dx is equal to, you know what is derivative of log x? 1 over x. 1 over log x into differentiation of log x is 1 by x. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss very important concept, that is secondary derivatives, second differentiations, or it is also called as successive differentiation. Now let us know what is meant by secondary differentiation. So just a function one time you will get the first derivative. If you differentiate the function again, you will get a second derivative. That means differentiating a function two times is called second derivative. If you differentiate one more time, you will get third. So that if you differentiate n times nth derivative, that is called a successive differentiation. Now let us consider to the concept of second derivatives, or it is also called as a successive differentiation. Suppose if y is equal to f of x is a function, then if you differentiate this with respect to x, then dy by dx is equal to f dash x is called the first derivative. And if you differentiate this again with respect to x, then what we will get? D by dx of dy by dx is equal to d by dx of f dash x. So d by dx of dy by dx is equal to d square y by dx square, and the differentiation of f dash x is f double dash x. So therefore d square y by dx square can also be denoted as f double dash x is called the second derivative of a function. So therefore d by dx of dy by dx is equal to d square y divided by dx square is called the second derivative of a function. If you differentiate one more time, you will get d cube y by dx cube, that is called third derivative. If you differentiate number of times n times, then you will get nth derivative denoted as dny by dxn, and that is called as a successive differentiation, one after the other differentiation. So therefore this d square y by dx square second derivative can also be denoted as f double dash x or y2 or y double dash or d square y. These are all representation for second derivatives. D square y or y double dash, y2, f double dash x are all called as the second derivatives of a function. Now let us come to the concept, that is d square y by dx, dq y by dx, etc. If you differentiate n times dn y by dx, and then it is called as the nth derivative. D square y by dx square is called the second derivative. dq y by dx cube is called the nth derivative, and so on. D square y by dx square, then d cube y by dx cube, etc. Nth derivative is denoted as dny by dxn. This is called the nth derivative, that is called successive differentiations. Now nth order derivative or successive derivatives is also denoted as like this, that is second order derivatives. Nth order is denoted as dny by dxn, and the second order is denoted as f double dash x or y2 or y double dash or d square y, etc. Now let us take for example, if y is equal to x to the power of 4, find d square y by dx square. What is given here? Y is equal to x to the power of 4. Differentiate first this. Differentiating with respect to x. So if you differentiate this, we will get dy by dx is equal to d by dx of x to the power of 4. What is equal to? You know d by dx of x raised to n is n x to the power of n minus 1. Here n is equal to 4. X to the power of 4 minus 1 is 3. 4x cube. Now differentiate this again. Differentiate with respect to x. Again differentiate this. So if you differentiate left hand side, what we will get? D by dx of dy by dx is equal to, here 4 constant, d by dx of x cube. Right. Now what is left hand side? This is called d square y by dx square. D square y by dx square is equal to 4 into differentiation of x cube is 3x square, that is nothing but 12x square. So therefore y double dash is equal to 12x square. So if you differentiate x to the power of 4 2 times, what you will get? 12x square is the second derivative for the given function, right? That's it. This is how we are going to differentiate. So here we are going to use all the methods: logarithmic method, parametric method, implicit functions, explicit, all type of problems will comes in the secondary derivatives. Let me take one example on each concepts. Now let us come to the first one. This is function of a function. So composite function. If y is equal to x plus 3 whole cube, then find d square y by dx square. Now differentiate this. Differentiating with respect to x. So if you differentiate dy by dx is equal to d by dx of x plus 3 whole cube. This is of the form d by dx of f of x to the power of n. D by dx of f of x to the power of n is n into f of x to the power of n minus 1 into d by dx of inside function f of x. So here what is n? N is 3. 3 x plus 3 whole to the power of 3 minus 1 is 2 into d by dx of x plus 3. Okay. Now this is 3 into x plus 3 whole square into differentiation of x is 1 plus 3 constant 0. If you multiply, this is equal to 3 times x plus 3 whole the square. Now differentiate this again. This is dy by dx. Now differentiate this again. Differentiating with respect to x, again what happens? This is d by dx of dy by dx is equal to d by dx of this 3 constant 3 into x plus 3 whole the square. So here 3 constant, again f of x to the power of n. N is 2 into 3x plus 3 whole to the power of 2 minus 1 is 1 into differentiation of x plus 3 is x. So this is equal to 6 times x plus 3. So therefore the second derivative d square y by dx square is equal to 6 times x plus 3 is the second derivative of the given function. So if you differentiate one time, differentiation of x plus 3 to the power of 3 is 3x plus 3 whole square into differentiation of x plus 3. X plus 3, x is 1 and 3 is constant 0. This is 3 times x plus 3 whole square. Again differentiate. Differentiation of x plus 3 whole square. So 3 constant, f of x to the power of n, n is 2, 2 x plus 3 whole raised to 2 minus 1 is 1 into differentiation of x plus 3, as usual x is 1. 3 constant 0. So 3 2s are 6 times x plus 3 is the required answer for this problem. Hope you followed. So this is how we are going to differentiate. This is how we are going to find the second derivative for the given function. Hope you followed. Now let us take a similar type problem. Now y is equal to log x. Find d square y by dx square. Same, what is given? Y is equal to log x. Differentiating with respect to x. If you differentiate with respect to x, dy by dx is equal to d by dx of log x. Now you know differentiation of log x is 1 by x. So dy by dx is equal to 1 by x. Differentiate this again. Differentiating with respect to x again. So what happens? D by dx of dy by dx is equal to d by dx of 1 by x. So you know the derivative of 1 by x is minus 1 by x square. That is d square y by dx square is equal to minus 1 by x square. Otherwise, if you want, you can take this to the numerator. X to the power of minus 1, n is minus 1. You know d by dx of x raised to minus 1 is minus 1. X to the power of minus 1 minus 1. Minus 1 x to the power of minus 2 is minus 1 by x square. So d by dx of 1 by x is minus 1 by x square. So that means differentiation of log x is 1 over x. If you differentiate 1 by x again, you are going to get minus 1 by x square. That means second derivative of log x is minus 1 by x square. Important problem for 2 marks. Okay. Now let us come to the next problem. If y is equal to x square plus 2x plus 2, find d square y by dx square. Very simple problem. Differentiate with respect to x. Differentiating with respect to x, then what we will get? Dy by dx is equal to term by term differentiation d by dx of x square plus 2x plus 2. So here differentiation of x square is 2x plus 2 into differentiation of x is 1 plus 2 constant 0. This is 2x plus 2. Dy by dx is equal to 2x plus 2. Now differentiate this again. Differentiating with respect to x again, what we will get? Differentiating with respect to x again. So then this is d by dx of dy by dx is equal to d by dx of 2x plus 2. So this is d square y by dx square is equal to 2 into differentiation of x is 1 plus 2 constant 0, that's equal to 2. So derivative of this is 2. If you differentiate once again, you will get 0, right? So d by dx of x square plus 2x plus 2 is second derivative is 2, a constant. Now let us come to a next problem. If y is equal to x cube plus tan x, find d square y by dx square. This is also a very simple problem. What is given? Y is equal to x cube plus tan x. Now differentiating with respect to x, if you differentiate with respect to x, what you will get? Dy by dx is equal to differentiation of x cube is 3x square and differentiation of tan x is secant square x, right? Now differentiate this with respect to x again. Differentiating with respect to x again, what happens? Here if you differentiate, d square y by dx square is equal to d by dx of first function is 3x square plus again d by dx of the second function, d by dx of secant square x. So here this is 3 constant, derivative of x square is 2x plus again this is function of a function f of x to the power of n. What is n here? 2 secant x into differentiation of secant x is secant x tan x. So therefore the second derivative d square y by dx square is equal to 6x plus 2 secant into secant is secant square x into tan x, that's all. So the second derivative of x cube plus tan x is 6x plus 2 secant square x tan x. See here, differentiation of x cube is 3x square, differentiation of tan x is secant square x. Again differentiate 3 constant, differentiation of x square is 2x, 3 2s are 6x. Again differentiation of secant square x, n is 2 secant x into differentiation of secant x is secant x tan x, secant into secant is secant square x tan x. So d square y by dx square is equal to 6x plus 2 secant square x into tan x. Hope you followed. Okay, very important and very easiest problem. Once if you are familiar with the list of derivatives, then you can easily solve this type of problems. Now let us come to the next problem. If y is equal to a sin x plus b cos x, prove that d square y by dx square plus y is equal to 0. This is an important problem for 3 marks. Now what is given? Y is equal to a sin x plus b cos x. Let us represent this as equation number 1. Differentiate, as usual differentiate, find d square y by dx square. Differentiating with respect to x, what you will get? Dy by dx is equal to a into differentiation of sin x is cos x plus b into differentiation of cos x is minus sin x. So this can be written as a into cos x plus into minus minus b times sin x. Okay, now differentiate this again. If you differentiate this again, differentiating with respect to x, again if you differentiate this, on the left hand side what we will get? D by dx of dy by dx is equal to d by dx of a cos x minus b sin x, right? Now this is nothing but d square y by dx square, a into differentiation of cos x is minus sin x minus b into differentiation of sin x is cos x. So you can take minus sign out, negative sign out, minus this is a sin x minus into minus plus b cos x. Now that is d square y by dx square is equal to, observe carefully, what is a sin x plus b cos x? That is given equation from equation number 1. A sin x plus b cos x is y. This is y from equation number 1 from 1. Now transfer y to the right hand side, left hand side. Therefore d square y by dx square plus y is equal to 0, which is the required answer. That's it. Very simple problem. See here, a into differentiation of sin x is cos x plus b into differentiation of cos x is minus sin x. Differentiating again with respect to x, d by dx of a into cos x is minus sin x minus b into differentiation of sin x is cos x. You can take minus out, take minus, negative sign, a common factor, minus sign out, then this becomes minus a sin x minus into minus plus b cos x minus a sin x plus b cos x from equation number 1 is y, it is given. So therefore d square y by dx square plus y is equal to 0 is the required answer. Very important and simple problem. Hope you followed. Okay, usually you will expect this type of questions for the point of examination. Now let us come to the next problem. y is equal to x cos x, find d square y by dx. So this is of the form uv into v. Here we are going to apply the product rule for this. Now what is given? Y is equal to x cos x. Differentiating with respect to x, if we differentiate this, what we will get? Dy by dx is equal to d by dx of x cos x. Now if you observe carefully, this is of the form u and v, product rule, first function. Here first function constant, differentiation of cos x is minus sin x, plus second function cos x constant, differentiation of x is 1. So therefore the first derivative dy by dx is equal to minus x sin x plus cos x. This is the first derivative. See here, first function, differentiation of cos x is minus sin x plus cos x constant, differentiation of x is 1, multiply minus x sin x plus cos. Now differentiate this again, differentiating with respect to x again. Again if we differentiate, left hand side we will get d square y by dx square is equal to d by dx of minus x sin x plus d by dx of cos x. Okay. Now you can take minus out. Again this is product rule. First function, second function. X into differentiation of sin x is cos x plus sin x into differentiation of x is 1. Again differentiation of cos x is minus sin x. Now multiply this with negative sign. Minus x cos x minus sin x. This is minus sin x as it is. Okay. Now this can be written as minus x cos x minus sin x is minus 2 times sin x. This is the required answer. That's it. See here, minus negative sign out, take minus out. Again product rule, first function into differentiation of sin x is cos x plus second function sin x constant, differentiation of x is 1 plus differentiation of cos x is minus sin x plus into minus minus sin x. Just multiply this quantity by negative sign, that's all. Minus x cos x minus into plus minus sin x minus x cos x minus sin x is minus 2 sin x. So d square y by dx square, this can also be denoted as y double dash. This is y dash and this is y double dash is minus x cos x minus 2 sin x is the required answer. Hope you follow. Now let's come to the next problem. Y is equal to x cube log x, find d square y by dx. Same, first differentiate this, differentiating with respect to x. Now differentiating with respect to x, so dy by dx is equal to d by dx of x cube into log x. So if you observe carefully, again this is also of the form uv product rule, first function x cube into differentiation of log x is 1 over x plus log x constant, differentiation of x cube is 3x square. Here one x and x gets cancelled. Y dash is equal to x square plus log x into 3 times x square. This is first derivative. Differentiating with respect to x again, if we differentiate this, differentiating with respect to x again, what we will get? D square y by dx square is equal to d by dx of x square plus d by dx of log x into 3x square. Now differentiation of x square is 2x plus again this can be differentiated using product rule again, uv method, first function log x into differentiation of x square is 2x, 2 into 3 is 6x plus second function 3x square constant, differentiation of log x is 1 by x. So this is 2x plus 6x log x plus 1x and x gets cancelled, 3x. So add 2x plus 3x is 5x plus 6x into log x. This is the differentiated answer. That's it. See here, x square plus log x 3x square, first function, differentiation of x square is 2x as it is. Again this is uv method, product rule, log x into differentiation of x square is 2x, 2 into 3 is 6x plus second function 3x square constant, differentiation of log x is 1 over x, x and x gets cancelled, 3x. So 3x plus 2x is 5x and 6x log x as it is. So this is the derivative of the given function. Now let's come to the next problem. This is also an important problem for 3 marks. What is given? Y is equal to e to the power of sine 5x. Let us represent this as equation number 1. Differentiating with respect to x, so dy by dx is equal to d by dx of e to the power of x into sine phi x. Again this is product rule, first function into derivative of the second function. First function is e power x into differentiation of sine phi x. So you know d by dx of sine ax, derivative of sine x is a cos ax. What is a here? A is phi. So d by dx of sine phi x is 5 cos phi x plus second function sine phi x as it is. Differentiation of e power x is e power x. So if you want, you can take the e power x common factor, e to the power of x out, and what is left over is 5 cos phi x plus sine phi x. Now differentiate this again. Differentiating with respect to x. Again, what we will get, d square y by dx square is equal to, again UV method, first function u, second function is this, e power x into differentiation of cos phi x is minus sine phi x into 5 sine phi x plus differentiation of sine phi x is 5 cos phi x plus second function is 5 cos phi x plus sine phi x as it is, and differentiation of e power x is e power x. Again product rule, first function differentiation of this phi constant, cos is minus 5 sine phi x plus 5 cos phi x. Similarly second function constant 5 cos phi x plus sine phi x as it is, d by dx of e power x is e power x. You can take e power x, again common factor out, e power x out, so multiply it, minus 5 5s are 25 times sine phi x plus 5 cos phi x, then this 5 cos phi x plus sine phi x. Now what is this equal to? So this can also be written as e power x into, see if at all possible to simplify, simplified, minus 25 times sine phi x plus 1 is minus 24 times sine phi x plus 5 cos x plus 5 cos x is 10 cos phi x. This is the required answer. That's it. Hope you followed. Okay. See here, differentiation of 5 cos phi x is minus sine phi x into 5 5s are 25 sine phi x. Differentiation of sine phi x is 5 cos phi x. Again d by dx of this constant e power x is e power x itself. So we can take e power x out, minus 25 sine phi x plus 5 cos phi x plus 5 cos phi x plus sine phi. So minus 25 plus 1 is minus 24, 5 plus 5 is 10 cos phi x is the required answer. Hope you followed. Okay. Now let's come to the next problem. Y is equal to log of log x, find d square y by dx square. This is also a very important problem. Y is equal to log of log x to base e. Very simple. Differentiate this, differentiating with respect to x. dy by dx is equal to, you know what is derivative of log x? 1 over x. 1 over log x into differentiation of log x is 1 by x. So 1 over x log x, 1 over x log x. Okay. Now differentiate this again, differentiating with respect to x again. Now again differentiate, this can be differentiated by the method of so if you want, you can take this to the numerator and differentiate, otherwise very easiest quotient rule, u by v, denominator d square y by dx square is equal to d by dx of 1 divided by x into log x. So this can be differentiated using quotient rule, u by v, denominator x log x into differentiation of numerator 1 is 0 minus numerator 1 into d by dx of denominator x log x divided by denominator square x log x whole the square. This gets cancelled, minus differentiate this using product rule, that's all. First function x into differentiation of log x is 1 over x plus log x into differentiation of x is 1 divided by the denominator square x log x whole the square. So here 1x and x gets cancelled. What is left over is minus of 1 plus log x divided by x log x whole the square. So this is the derivative. Minus 1 plus log x divided by x log x whole square is the derivative of the function. That's it. Okay. Now, so otherwise you can also differentiate by taking this to the numerator, x log x to the power of minus 1. So here n is equal to minus 1 x log x to the power of minus 1 is minus 2 into d by dx of inside function x is x as it is, differentiation of log x is 1 over x plus log x into differentiation of x is 1. These two gets cancelled. So minus 1 over x log x whole square into this is 1 plus log x. Bring this to the denominator, d square y by dx square is equal to minus 1 plus log x divided by, this comes to the denominator, x log x whole the square. Same answer, minus 1 plus log x by x log x whole. So you can take by UV method or take this to the numerator and differentiate. Any method you can follow to differentiate this function. So in both the cases you will get the same answer. That's it. Okay. Let us come to the last problem in this session. Y is equal to 5 cos x minus 3 sin x. Prove that d square y by dx square plus y is equal to 0. This is also very important and easy problem for 3 marks. Now what is given? Y is equal to 5 times cos x minus 3 times sin x. Let us represent this as equation number 1. Differentiating with respect to x, differentiating with respect to x, dy by dx is equal to 5 into, you know, d by dx of cos x is minus sin x, minus 3 into differentiation of sin x is cos x, minus 5 sin x, minus 3 cos x. Differentiate this again, differentiating with respect to x, differentiating with respect to x, again what happens? Left hand side, d square y by dx square is equal to d by dx of minus 5 sin x minus 3 cos x. So this is equal to minus 5 into differentiation of sin x is cos x, minus 3 into differentiation of cos x is minus sin x. Let me write one more step. So this is equal to minus 5 cos x minus into minus plus 3 sin x. Now you can take negative sign out. D square y by dx square is equal to minus out 5 cos x minus into plus it is minus 3 sin x. Now if you observe carefully, d square y by dx square is equal to minus 5 cos x minus 3 sin x. 5 cos x minus 3 sin x is equal to y. Now transfer this, so therefore d square y by dx square minus y becomes plus y is equal to 0. That's it. D square y by dx square plus y is equal to 0, which is the required answer. That's it. Very important and simple problem. Just differentiation of cos is minus sin, sin is cos. Again differentiate it, minus 5 as it is, differentiation of sin x is cos x, minus into differentiation of cos x is minus, minus sin x, minus into minus becomes plus, you can take minus out, 5 cos x minus into plus it is minus 3 sin x. 5 cos x minus 3 sin x is nothing but the given equation, that is equation y. So this is represented as y. So we can represent this as y. So minus y. Transfer minus y to the left hand side, it becomes plus y. So therefore d square y by dx square plus y is equal to 0 is the required answer. That's it. Hope you followed. So these are few problems based on a second derivative. This is how we are going to solve second derivatives problems. So you will expect one question from this for 3 marks. That's all regarding today's session. Let us meet with the different concepts in the second derivatives in the next session. Don't miss the class, attend the class. Next session is very important for the point of examination. You will expect one 5 marks question from that. That's all for today's session. Let us meet with a different concept in the next class. Thank you very much.